This is Chef Whips Up Awesome with Nginx. If you're not familiar with Chef, who's familiar with Chef? I know some of you are because you talked about Chef in your talks and I had to take a bunch of slides out. So Chef is the company behind the Chef configuration management system. We're currently based in Seattle. We also have offices here in the San Francisco area and in London, new office there. And we have remotes all over the place. So some of the stuff that our server team works on, those folks are all over the United States, actually. I myself, my name is Mandi Walls. I am currently a consulting director for Europe. I was the technical practice manager for our US team. And if you look on our YouTube channel, I gave our demo for Chef Comp, so I get around. I'm also a recovering AOL server sufferer. So for you folks living the life in web server land, I spent a number of years working at AOL with a Tickle and C-based plant, which was terrifying. So what we do, Chef is a tool with a client-server model. So it's configuration management, but there's an agent that runs on all of the nodes that talks to, most of the time, a centralized repository of knowledge about your infrastructure. So there's components that live locally on your node, plus stuff that lives remotely on the server, and that's where we have deployed Nginx. We provide a hosted service for this server component so that folks that are just getting started with Chef or have different requirements, whatever it is, for their configuration management tool can make use of our expertise in running Chef server rather than deploying their own. We also ship an on-premise version of this that you can pay us licenses for, and there's also an open source version. For our upcoming Chef 12 release, all of these are exactly the same. So there's a blog post from September from Adam Jacob, our CTO and founder, about what it means to sort of bring all of these things in to be the same. So Chef in the world is comprised of three sort of places that work gets done. On the bottom here is the administrative workstations where people write what we call recipes. So it's configuration code that describes how systems should look or behave. On the upper left-hand side is the Chef server, and that's a bunch of storage and search and other services behind Nginx. And on the right-hand side are all the live nodes, and they can be anywhere on-premise, in the cloud. They can be virtuals, they can be reals, it doesn't matter. They're just something with an operating system on it. We're also, working with containers and all kinds of things like that. So behind the scenes, the Chef server is fronted by an Nginx component, and then there's a service layer. And the service layer changes as Chef server has evolved. We'll talk about that a little bit. We have a web UI, and then there's an API, and then some additional services that are then backed by a permanent data store. We, at any time, may switch out, upgrade, change any of these components, and part of what we rely on Nginx to do for us is make all that transparent to our end users. In the internals, as we break them up for this example is actually our high availability topology that we ship with the on-premise Chef server. The service layer can live on a separate set of systems, and that's where Nginx lives right now. It's in those front ends. And in the back ends, we are relying on Redis and using OpenResty, which hopefully you went to the talk about the Lua stuff and all that other great components there. And we're making use of those to do a lot of heavy lifting as far as routing and stuff like that for our for the front end on the API server. So yeah, Chef server relies on Nginx with OpenResty. We use Redis for all of our customization. Our operations team and our server development team make use of routing features through Nginx and Redis so we can manage all of the API components that come in through the Chef server. So the API itself has a couple of different components. We have global components like users. So if you're an actual user on the Chef server, you have a global reaching account. And then there are organizations which allow you to shift spheres of influence for pieces of infrastructure into smaller groups. And the organizations are all multi-tenant, so they're completely separate from each other. So as we work through how the API goes together, we have some of these components that are global, like the users, and others that are partitioned off into the organizations. So each organization has its own API endpoint for its main components, and then subcomponents hang off of that endpoint as well. The endpoints themselves can be served by any number of backend services, in addition to all of the data and search and storage and all those sorts of things, those sorts of services that are back there. There's also all of the authentication system for the users and some queuing systems for messages and other things that also go on behind the scenes there. Over the past couple of years, the Chef server has undergone a lot of evolution, mostly for performance reasons. We wanted to get a lot more bang for our buck out of the Chef server, so we've moved a lot of things around. And all these major components have been changed behind the Nginx front end. Nginx is one of the oldest components of the Chef server. It's been in there a long time. Originally, all the web tier applications were written in Ruby, and a couple of years ago, we switched them all to Erlang for performance reasons, and we reaped a lot of benefit out of that. And our users didn't see a lot of bumps along the lines of how things got changed. Originally, our storage was in CouchDB, which made sense because all the documents in Chef are JSON-based, and CouchDB is a JSON-based document store. And while it seemed like a good idea at the time, we kind of reached the edge of what Couch could do for us, and we've moved to Postgres. There will be then no CouchDB in the upcoming Chef 12 release, and all of those things have come into to play as we've moved routing around and the services keep moving around in Nginx. So we picked Nginx originally for the flexibility, the extensibility, the configurability, all the things that we sort of espouse in our own tools, we found in Nginx, so that we could make use of all of the things that we needed as the service was growing, as it was evolving, especially in early days, is when you're working with a tool, you don't know exactly how people are going to use it until you actually give it to them. And as you discover what they do with it, then you can add more things, change the way something works to reflect how they want to do things, and then continue to add to it. So in real time, because we actually have this hosted service rather than just a system that we ship to users, we use all of the Nginx and Redis hookups to help us do migrations and replacements of all the services behind our API. And we can do those endpoint by endpoint, so that as functionality is migrated from an old service to a new service, we simply redirect it endpoint by endpoint. We can also redirect specific users based on their organization. Since the API endpoints are built with those organization names right in the URLs, we can shift people around as well. So that if we get to the point where one organization is making heavy use of resources, we could give them a different use, or a different pod, or a different set of servers to make use of. So we can redirect specific endpoints as we need to. Anything that we do a long-term refactor on doesn't happen quickly, right? So it might take us a long time, and we can move things around. We also use that feature for dark launches. So the new components go into the server, they're ready to go. We can use them for testing because we can do a lot of very specific rules and things on the configuration of the Nginx front end. So our on-premise topologies, so creating another layer of complexity on top of running our own service for the Chef server, we ship this, right? So we package up all the components of the Chef server and we give it to people. And it's available on GitHub. You can download it. You can download the entire built package from our website. But part of giving Chef server to individuals to run in their infrastructure, we had a lot of different needs that we needed there. Chef server in the hosted side, we can expand. It's a lot of specific gear that we know a lot about. But when we give it to a customer or another user downloads the open source functionality, the open source server, then we don't have any idea what they're going to run it on. So part of all of the configuration that we give them has to be flexible enough to meet all of their needs. So we have put together a number of different sort of canned topologies so that they can run the entire stack on a single server. They can run the stack on a tiered system where there's any number of front ends that are running Nginx and a couple other small components. And then there's backends that run, one backend that runs all the backend services. And we also ship a couple of high availability topologies that allow you to use DRBD, so a block-based replication, or now AWS with all the blocks in their services. The new one that we have for Chef 12 is replicated. So we can replicate, we sort of do a replay replication between a parent Chef server and child Chef servers, and all of that is implemented through the API. So there's simply a set of new URLs that hang off the API endpoints to allow the parent server to surface all of the things that have changed in an organization over a specific period of time. And there's a daemon that sits on the child servers that pulls in all that information and replays it to its own set of endpoints so that all the data that was changed on the parent server is now replicated into the child servers. So with Chef Omnibus, we basically give Nginx to unsuspecting users. When I joined Chef 3 years ago, it was ops code at the time, I had actually never seen Nginx before. I'd worked in Apache systems and with AOL server. And we basically put Nginx in with the rest of the services that we need. The Omnibus system that we use allows us to package up all of the stuff that our server needs so that you get one big package that contains the Nginx plus Solr, Postgres, RabbitMQ, all the other components that come along. So anyone who's running a Chef server is actually running a rather complex Nginx setup without really even knowing it. It's just in there and hanging out with them. We also do this with the Chef client. It comes with its own Ruby and a bunch of gems and all these other sorts of things that we need so that the Chef client will work correctly. So let's take a look quickly. Well, we can take some time. We got time. This is where our code is. So we're on GitHub. We're still ops code as our organization name on GitHub. And all of our packages for the Chef server stuff are under ops code omnibus. So this is where we keep all of the code that's going to ship, plus all the testing code and all those other components are there. There's still some legacy of the early deliveries of the on-premise Chef server, which we called Private Chef. It's all just Enterprise Chef now. And our Nginx is down here in a set of cookbooks. And these are, if you went to some of the other talks that mentioned Chef earlier today, the way Chef gets built up, you have recipes that describe some resources. They get packaged up into cookbooks that are some kind of functionality. Our Private Chef cookbook defies that a little bit. A lot of things are kind of dumped in together, but one of the things that is here is our config for Nginx. It looks like I fell off the network. So let's push that back up. There we go. So our template for Nginx and all the things that it's doing just right out of the box without any of the special stuff that we do on Hosted Chef is about 150 lines long. This is our template for building up all of the things that we need Nginx to be doing so our users don't have to care that it's even there. And you just see that we've got a lot of things that are specific to our deployment. We use a templating engine called Redis. That's what the ERB ending stands for. So you see a lot of places where we're putting in specific config for the topologies that we're using and for the things that we're shipping to users so that they don't have to get into these configurations and deal with that stuff. And all that just sort of is in there. If we have a specific set of topologies for whether or not the Nginx is separate from the rest of the stack and all those things can be then abstracted so that we don't have to worry about those at the granular level. And there's certain things that we ask people to know for us, like the FQDN of the Chef server when they deploy it, and that goes into the template as well. So that's pretty much where that stuff all ends up living. We also test our routing components, and this is something new that our server team has started doing. They are writing the tests in Lua so that they can put together a set of conditional templates and then test all of them out through. And those things are also here in the Omnibus package under tests and then routing. And there's a handful of them here. They're all put together so that we can run a bunch of checks when we make changes before they get deployed into production. Most of the time, our users who run on-premise Chef servers wouldn't necessarily be working with these. These are here for us to test when we make changes to hosted Chef. So if we're moving an endpoint or moving an organization to a different data store or whatever the other pieces of evolution are that we're doing, we can test that out beforehand. And there's a whole set of them here. And the person on our engineering team who put these together is Mark Paradise. And we're just getting started with some of this stuff. You can see that we're digging around in specific endpoints for all of the tests that we're doing, sort of dynamically as they get changed. So as we continue to evolve, Chef is not a static project by any means. We have other components that we're going to add to the Chef server. There are add-ons that are coming. We hope to be able to potentially allow other users to add stuff to the Chef server. We'll see how that goes. We're also maybe looking at more expressive topologies. We've had folks ask if we can facilitate moving things like Solar or other backend components that are really heavy out of the main structure of the Chef server. So that would be another place that we would be providing more robust Nginx components. And eventually there'll be changes to the APIs for new features. So as we roll things out and we make breaking changes, we can migrate bits and pieces of the hosted service as we continue to roll out new releases for the on-premise server as well. So our Chef server team is a bunch of really awesome people. Some of them are Twitter and some of them aren't, but these are the folks that are sort of responsible for doing all this stuff for us. And there were a couple of talks at ChefConf this year about components of the server. That's all on our YouTube channel as well, which is Get Chef. And for the Lua stuff in particular, Mark Paradise is our knowledgeable guy on all those sorts of things. So if you want to know more about Chef, I wasn't going to go into it because a couple people already covered Chef. We are getchef.com. LearnChef.com is our sort of beginning tutorial, our doc site, where we are. If you want to know more about or talk to our engineers in particular about how we use and abuse Nginx, Chef Hacking is a good place to look in there. The engineering team hangs out there. And all of our stuff is still under ops code on GitHub, so you can nose about in there as well. And now I'm happy to answer questions, or you can go drink beer. I told you it'd be quick. The end of the day, everybody's exhausted. Like if you sat through some of these talks, it's pretty heavy stuff. So. Okay. Go drink.